Good morning, everyone. Thank you for having me. This is joint work with Shumin Tu and Claudia Steinwender, and we are going to be interested in talking about Chinese science. So, I think one thing that will not come as a surprise to this audience is that Chinese science has been rising. Quantitatively, it's kind of undeniable, and you can look at it in many, many different ways. Here we're looking at China's share of world publications, but we could also look at citations. We could look at the number of highly cited researchers. It is true in general, it is true in specific fields, it's just kind of an overwhelming fact. And so what we're going to ask is whether, in this context, Chinese scholars actually contribute to push the scientific frontier out. Is it the case that Chinese research is actually incorporated in the research of researchers from other countries? We know from the work of Nate Rosenberg and Joel Mokyr and many others that just because you produce knowledge, that doesn't necessarily guarantee that others are going to be able to build on it. So we want to ask whether China's research is fertile, whether Chinese scholars actually provide broad shoulders for follow-on researchers, in particular from other countries, to actually stand on. And certainly this quantitative rise of Chinese science is suggestive of something like fertility, but one would have to look at whether those citations, for example, come from researchers that are actually engaged in frontier investigations. So here is the very simple kind of thought experiment that we're going to try to implement in the paper. We're going to think about two very similar papers from the labs of two different elite private investigators. And they're going to be published in the same year, in the same journal, and hocus pocus, let's assume they have the same underlying quality or potential, right? We're still not going to make them in the same narrow subfield because we don't want them to compete for citations, okay? And so the only thing that's going to be different between those two papers is that one is going to be authored by a Chinese researcher and the other one by the lead author is going to be from another country, like Germany or Korea or France, interestingly, not the US, okay? And what we're going to ask is whether Chinese papers attract more or less citations from a frontier country, that's the US. Okay? And so the US is kind of in this paper is kind of our neutral ground, and we're picking it both because the US is a frontier country, but also because the US is large in size, so we're going to be able to do lots of things with those citations that arrive from the US.
Yeah. When you say a Chinese author, do you mean somebody working in China? Or
yes.
Somebody Chinese could be working in the US?
Well, we're going to leverage that distinction, but think of location in China, right? It's going to be about the location. So, in the spirit of this is not a mystery novel, let me kind of briefly summarize what we're going to find, right? So what we're going to show is that Chinese papers suffer from a very kind of obstinate citation discount, and it's kind of large in magnitude. It's about 30% less citations, right? And so most of the paper is concerned with what explains this? Where does this come from? So we try to do a good job in terms of holding the quality of the paper constant, right? But of course, you're going to ultimately be the judge of whether we do a good job of that. You might say, well, maybe it's not about quality, it's about perceived quality. It's kind of hard to measure perceived quality as distinct from actual quality. We're taking a cut of that by looking at variation to the extent to which papers appear in subfields that are heavy or not heavy in retraction activity. We're going to show you that doesn't seem to matter. One thing that could be going on is that maybe there's animus against Chinese researchers. That's certainly a possibility, but we're going to show you that we don't find any evidence of a discount that applies to Chinese researchers located outside of China. So that doesn't really square with that hypothesis. Now, in the end, most of the evidence that we're going to have regarding the mechanism is that it's probably something that has to do with reduced awareness and or shallower network of Chinese researchers in the US relative to researchers in other countries. Okay? And we'll show you how we kind of try to measure that. Okay, so I'm going to tell you a lot about the setting, the data, and we're going to run through a bunch of results. Now, we focus on chemistry. Okay? Why do we focus on chemistry? In some sense, we thought that this paper was going to be more interesting if it focused on an area of science where there's a long tradition of excellence in China. And if we're thinking about the chemical arts, the tradition of excellence in China goes back, thousands of years, right? So it would make, in our mind, less sense to focus on fields that are kind of relatively young in the Chinese setting. Just to provide some context, if you're looking at, for example, the distribution of China's top researchers across fields, you can see that chemistry and material science, and those are kind of domains that are joined at the hip in some sense, those are the leading domains, right? Even ahead of things like engineering and computer science, and certainly ahead of the life sciences, right? If you're looking at the share of publications or the share of highly cited researchers in chemistry, China is basically the #2 country after the US. Okay, so it seems to be important as a domain within China. Okay. So the first thing we do is we do something extremely simple, is we look at the raw data. Okay, so we're looking at all papers in chemistry. Okay, all papers in chemistry where the authorship team is from a single country. Okay, so we have all German paper and all Korean papers and all Japanese papers and all Chinese papers. Okay, and we're then counting the citations of these papers in the US, where in the US here we're also making it simple. It's from papers with all US authors. Okay, so we're not in this cut worrying at all about sort of international collaboration, right? And what is immediately important is that Chinese authored papers receive 50% fewer citations per paper in the raw data. Now, you can cut that by quite a bit by controlling for things like publication years and number of authors and putting in journal fixed effects, right? But still, it remains, and it's quite large, right?
I guess European researchers have this similar, but probably less discount.
No, I will show you. We're going to look at all that, right? One thing I will show you is that this discount is uniquely Chinese. Okay. And by the way, and this is
talking to the US, right? So
yeah. So the US is only on the left here, right? So, but it's China versus Germany, Korea, Japan, all those other countries, right? By the way, I could show you. This is not the focus of this paper, but I could show you the converse of this one, where we're looking at the extent to which Chinese researchers may or may not discount US research, and that is not happening, okay? So it's very much one-sided. Okay, so we want to go beyond, right, patterns in the raw data to see if we can really try to first hold constant the quality of the research more than just controlling for journals, but as well use the granularity of the citation data so that we have a chance of saying something about why might this pattern actually appear in the data. Okay? So what are we going to do? We are going to start from looking at elite academic scientists in chemistry. Okay? And so what's an elite academic scientist in chemistry? It's a very simple definition in this paper. We're going to basically look at individuals in the top 1% by number of publication in a set of 31 elite chemistry journals. Okay? And the reason why we can do it is that all those journals are indexed by PubMed, and PubMed has been author disambiguated. Okay, by the work, it's the work of Torvik and Smallheiser, and so it's in some sense quite easy to just say, okay, I'm going to pick the top 1% of researchers by number of publications in those journals. Okay, and we're going to focus on all the non-US scientists. Okay, so we're throwing away the US, and that eliminates about 40% of those scientists. Okay, and then what do we do with those roughly 750 people? We stalk them online. Okay, so first we ask them for their CV, and we get about 30% of their CVs just by asking them, but then we kind of like one by one, it's very much a retail operation. You know, we go on the webpage of their lab, we download their CV if we can find it, we collate information from all sorts of sources, and in the end, for 99.5% of those researchers, we can reconstitute the entire career from undergraduate to the present day, okay? Including, grad school, postdoc, the location, all the employment spells, and we're gonna have obviously a very precise measure of all their publications, okay? So we have a sample of 751 PIs. 21% of them are Chinese, and by that here I mean located in China, right? And 80% are non-Chinese. Okay, and so we have all those publications. We're also going to get all the citation information, and we're going to parse all those citations according to the addresses in the citing paper. So we're going to know where the citations come from, and that's going to play a very, very important role in our analysis. Otto?
And how do you assign a country when you have those tens of authors with different locations?
So sometimes we need to, So sometimes we need to use for some analysis we're going to use fractional addresses, but sometimes we're also going to be focused on the address of the last author, which is kind of the PI in chemistry, and we're going to play with that in some sense. We're going to totally embrace the fact that, yes, those citing papers, they don't have to be all US, they could be US and something else, right?
So in chemistry, the last author is the PI.
Yep,
Person.
that's
so
right.
Your name is last on the paper.
Yeah, but I was going by economic norms. I was just making myself small. Okay. All right. So, so how we're going to analyze this data, right? So what we want to do is for each Chinese authored paper, we'd like to find its twin in the data, okay? And we're going to do that by matching, okay? So we're going to do that very much based on observables. And we have lots of papers, so we can have quite a few observables. So we're going to exactly match on journal and publication year, and we're going to coarsely match on number of authors, on the degree year, okay, of the PI. So you need to think about, say, the Chinese PI and the German PI to be of approximately the same age within 3 years. Okay, and then we're going to have, and notice the quotes around the word quality, right? We're going to have a measure of quality on top of the journal, which is going to be, and I'm going to provide more detail, but this is clearly important. I'm going to tell you more about how we do this. The number of home debiased citations from the world, excluding the US. Okay? And then we're going to match at the strata level. So the strata is going to be defined as the union of all those matching criteria, and that's going to give us also a set of regression weights that we can use in the regressions. Okay. I'm going to provide more details on this. In particular, I want to spend a little bit of time on this measure of citation as an indicator of paper quality. Okay. So think about the citations received by an article P, right? You can bin them into 3 different buckets, right? There's the citations that come from home, there are the citations that come from the US, and there are the citations that come from all the other countries, okay? So we're going to get rid of the citations from the US because that's our outcome, okay? We're going to keep 100% of the citations that come from the rest of the world, but we're a little bit worried about the citations that come from home, because that is obviously affected by, in some sense, how large your country is, and also what is the propensity for local researchers to cite local, which we might call the home bias. Just like we have a home bias in trade in goods, we can have a home bias in citations as well. And this is really important here because, as it turns out, China exhibits the largest home bias in citations. So you can look at this graph, right? The share of home citations in total citations is highest for China, right? And so you might say, well, duh, China is big, there are lots of researchers, stands to reason, right? That may just reflect the size of China. But in fact, what we do is to kind of use a dartboard approach to think about how much of that home bias, how much of that disproportionate share of local citations for China is beyond and above what you would expect, the size of different countries, thinking about, for example, as the share of publications as being the benchmark, right? And so that's going to give us, I'm going to skip the details, but that's going to give us for each country, in some sense, a factor delta H, which is the home bias factor, right? So that delta H is just, it's a number between 0 and 1. And do I have it here? Let me just see. Just want to show you the distribution. Okay. All right. I guess Beamer is playing tricks on me. So it captures the extent to which a country tends to cite for itself over and above what one might expect just by looking at the size of that country. Chad.
So the home bias thing, I understand. So I guess I'm puzzled by using citations P, rest of the world. Maybe go back to So it's citations P, US. That's your outcome. That's what you're worried about. But maybe the same thing that keeps U.S. inventors or U.S. citers from citing Chinese patents keeps European citers from citing Chinese patents. And then your citations P, rest of the world, seems like it would be reflecting the same problem in the U.S. and maybe it might not be a good thing. I know you started.
Right. So I mean, I think that's right. And the way, like the choice of China and the focus on China, in some sense, right, is completely arbitrary. Like we could choose any other country. And in fact, I think one thing we're going to do to alleviate this concern is that we're going to also show you what happens when we decide to make another country than China pivotal. Okay? So I think that's going to help us put some things in perspective. I also want to say that we're very worried that, oh, sorry.
Happening, I mean, there is a fast rise in patenting from China, and it takes a while until people are identified. And maybe what's going on is that, maybe there is kind of learning process that will go on. So suppose, but because the rise is so fast, there is, there are two offsetting effects. You see what I mean? That, they rise so fast. Of course, you learn about them, but there are many more and many more. And so,
right.
Could there be something? And that's why
there could be.
This constant, that goes at very much.
So there could. So there could be one thing I'm going to show you though, and this is we thought maybe like this. Right, but that would call for, I think, a shifting discount over time. And what we're going to show you is that it's actually quite stable. Right? Our intuition, our prior actually was it was going to go down, right? Over time, the discount was going to go down over time, as in some sense Chinese researchers get, in our mind, closer and closer to the frontier. We're going to show you that that's not what we find. It's really stable.
Name?
Sorry?
Would there be a name issue? People in China whose last name is Wang?
You might think so, right? So this is the beauty of. Okay, this is the beauty of the authority project, right? We disambiguate those. So PubMed has been disambiguated, but you might think it's not been disambiguated well for Chinese researchers. But the thing that really helps here is that we have the CVs of those researchers. So we have what they study, we know the main keywords, and we also know that they're chemists and in which journals they publish. So we can do, I think, an unusually good job at not just taking the disambiguation that comes from the algorithm for granted, but actually checking it. And we feel very, very confident.
This is not what I had in mind. What I had in mind is we know that there is some chemist. I'm a chemist working in Collège de France. I know there are some chemists in China who did some great work.
I see.
How do I know which one it is?
Right. I agree with you, but then you would expect there to be a very, very large Korean discount.
Yes.
And there isn't. So there are lots of things we're going to be able to do there. Sydney?
Yeah, I was wondering, maybe you said it and I didn't get it, but how do you deal with the cohort paper where you have a PI who is Chinese and you have other authors who are American or whatever? And also, I mean,
We're using it. We're going to use it,
okay,
right?
because I was wondering if you really want to match, exactly to know what's the premium for US versus China, and well, shouldn't you have the same nationalities? I mean, I know it must be quite difficult. But
So the thing is, you can't match. If you insist on matching for everything, you can't find matches. But what you can do is, and the approach that we're doing, which is, I think, pragmatic, is we match for things that we view as kind of like non-negotiable, and all the rest we measure precisely, and we're going to look at the extent to which the probability of citation shifts with those things. So we very much want to attend to the composition of the teams, right? So we're going to do that. Let me see. I think I've lost my thread a teeny bit. The one thing I want to tell you is, in some sense, when we started this project, we were very afraid, or we were weary of any assumption that we could make in terms of holding, quote unquote, the quality of the paper constant using citation information. So we did it every which way. Okay, we did it where we got rid not just of we got rid of the entirety of the home citations, right? Or we don't control for citations at all. Or we're using our home debiased number of citations. And the point is, it turns out not to matter for not just the existence of the discount, but really its magnitude. So that I think puts our mind a little bit at ease. Okay, now, we have those papers at risk of being cited, right? We have a Chinese paper and we have, say, a German paper, right? Now, we want to think about what are the papers at risk of citing that paper, right? Not just those that actually cite the paper, but those that could have cited the paper, right? And so what we want to do that is three things, right? So we're going to want all authors to be affiliated with US institutions, right? So the citing paper, we're going to look at only US teams, right? Or kind of pure US teams, if you will, right? Obviously, if you're going to cite a paper, you need to be published after, okay? And the last thing is we want that, and we're going to look at potentially citing papers that are topically related to the source paper, right? And the question is, how do you do that? How do you do topical relatedness? And here we are helped with a content similarity model called PMRA that is integrated into PubMed, right? And this is, we're not talking about ChatGPT here. We're not, it's kind of like 1970s natural language processing, but this is how researchers actually navigate the literature today, right? If you search PubMed, you can invoke that algorithm to look at related articles, right? And so each paper has a set of intellectual neighbors, if you will, right? And we're going to look at those intellectual neighbors as like the risk set for papers that could have cited the focal paper, but many of them actually did not, right? But that's the risk set that's going to allow us to model the probability that a potentially citing paper actually cites the cited paper. Am I making sense? I'm hoping I'm making sense. Right, so here is how it works. Right? So here's one paper in our data by a Chinese PI, right? And here you have ranked the set of neighbors for that paper, right? And that's going to be our citation risk set, right? Just a little graph to make this a little bit clearer. So we have our source article, right? So paper 1 and paper 3 actually cite the source, right? So they are published after the source article. They have US authors, and they're on a related topic, right? Paper 2 is on a related topic, but actually doesn't cite, right? And then outside the risk set, you have papers that may well cite the source, but they are not topically related, so we're getting rid of it. And then you have, of course, papers that don't cite the paper or are not even topically related, so they are definitely out of the risk set, right? By the way, we've done a variation of our analysis where we're adding to our risk set all the paper 5s of the world, meaning the papers that are actually citing, even though they may not be topically related. It turns out it doesn't change the empirical picture. Okay? All right. Frankly, once we've done that, it all becomes very easy. Because, right, we have this match data set, we have the citation risk set, and then we are going to run linear probability models that we're just going to saturate with fixed effects. Right? So we're going to control for a lot of things. In particular, we're going to have fixed effects for the strata, for our matching strata, right? So all the stuff that we are matching on is completely controlled for, but also other things that we're adding, other things that we're measuring, investigator gender, topic similarity, fixed effects for each differences in year between the cited and the citing. I mean, we are very liberal in our inclusion of fixed effects, right? And what we're going to be interested in is the indicator variable for, hey, I'm located in China, and then for, hey, I'm located in China, interacted with stuff, right? And the stuff is the Xij here, and the Xijs are going to be things that are going to help us explore the heterogeneity within Chinese researchers, right? So, for example, it could be, like, just to give you an example of what Xij could be, right? Xij could be something like, there's an author on the citing paper that actually has a Chinese name, right? That would seem to be relevant. Or there's an author on the citing paper that's a former co-author of one of the papers on the cited paper. That could be relevant. We're going to capture all of that. Okay? Okay, so time for some results. How am I doing with time? I've lost track.
15 minutes, is that okay? 15 minutes?
It will have to be, right? When you say, is that okay, you're inviting me to take more time than I've been allocated. I think so. Okay. So this is kind of our baseline specification where we just have the kind of this Chinese investigator indicator variable and like all of our fixed effects, right? And here, this coefficient, it's hard to know what it means in terms of magnitude, but it's basically a third of the mean, or sorry, a fourth of the mean, right, of the dependent variable. Okay, so that strikes us as pretty big.
Yeah.
Yep.
I mean, how does this look like when you start dropping the fixed effects? So some of those fixed effects you could think of as bad control, like the total number of citations to the investigator.
In the past, right?
Yeah, but still. Right? If there's bias against Chinese, then you
Got it. No, I think that's a fair point. I agree. So are those bad controls where we felt like, so just let me explain why we include them, but yes, we can drop them with no harm to the results. But the reason, the reason why we chose to include them is because when we look at, and we have, I could show you the table of descriptives, right? So at the paper level, things are really, really well matched, almost by construction, right? But then there can still be observable differences about the researchers, right? That are kind of glaring, right? And in particular, the non-Chinese investigators in the data have kind of longer CVs, even controlling for age, right? And have accumulated more citations and more publications, right? in the past relative to the Chinese investigators, right? Even though the two papers that we are comparing are very, very comparable. So we thought, okay, let's control for that stuff. But I think you're right. Damn if you do, damn if you don't, if you think about it. We can, I should not be so bold. I should say, last time we looked at this without is a long time ago, so we should redo it. I think that's totally fair. Okay, so the first thing we're going to do, and I'm going to try to, in some sense, I think I'm going to skip that because this is not, it's not the most interesting part, is the question is, can we kill this discount just by controlling for more things, right? And I'm just going to give you a list of things that we've tried, and I just want to tell you in advance, there's nothing that we can include, that we can add on the right-hand side of this regression that would kill the discount, or even that could move it, like change the magnitude in a major way, right? But it's worth thinking about those things just because those are also the things we're going to interact with the China effect to explore some of the mechanisms, right? So one thing you might think about is communication, right? There could be language barrier with respect to communication with Chinese researchers that maybe, is different certainly from, what might exist between, say, a Canadian researcher and a US researcher, right? It could be that Chinese researchers are less likely to have a network with US researchers to disseminate their work, right? In a current era, which is not strictly relevant because, in some sense, the end of our observation period is the year 2018, so that's kind of pre-COVID and pre the freeze in relations, in scientific relations between the US and China, which I think we're going to hear about in the next paper. But even though there might still be difference in the networks of Chinese versus, say, European researchers in the US, right? It could be that Chinese researchers, really specialize in subfields that are not active in the US, right? That's kind of like clustering in intellectual space, and that explains what we find, right? It could be that Chinese investigators are kind of unfocused. They study lots of different things, and that makes it harder for them to disseminate their research in the US relative to other researchers, right? Or it could be some reputation story where Chinese research may be perceived as being lower quality, even though according to our observables, it's not of lower quality, right? So I'm going to skip those slides where we're adding things on the right-hand side, okay? Because I think that's actually not what is super interesting. And I'm going to focus on a few other things, and as well as show you the evidence when we start interacting those factors with the China effect, okay? Okay, so this figure I think of particularly important, right? I kind of hinted at this earlier, right? We are contrasting China with the rest of the world, excluding the US, right? But what if instead of picking on China, we picked on Switzerland or Germany or Japan, right? And certainly we can do that for every country that's kind of large enough in the data, we can do it. Right? We can apply exactly the same approach and look at the extent to which their research is being discounted in the US, right? And what you can see is that for all those major countries, and here major is, it's how many articles you contribute in our data set. So I'm sorry to say that France is too small, at least in our data set, to make it into this picture. But rest assured, to the extent we can do it, there is no French discount. There's also no French premium, okay? And what you can see is that it's uniquely...
Still the 1% of elite research?
Yeah, this is all the same, right? We're just shifting the emphasis. We're pitting, in the first one, we're pitting Switzerland over everyone else, and I'm just graphing the magnitude of the benchmark estimate that we had in the first data slide I showed you.
Everybody else includes China?
China is, yes, so China then moves to the control group. So Chinese investigators become eligible to work as controls, right? So it's symmetric in that sense. Sydney?
Did you try with, I don't know, maybe it's not critical size, but with a developing country like India or whatever? Because these are all developed countries, so maybe.
So the thing, what's happening with India is, in some sense, they contribute. There are some Indian investigators, but they contribute too few papers on the whole. That basically you have a very, very wide confidence interval, and I think it's not as interesting. We can do it. Well, so here is one that's particularly interested. You know, one country we could think about? Fake China. So what is fake China? Fake China is composed of researchers in Taiwan, Hong Kong, and all Chinese PIs working in other countries. So think about, I think we have 2 in Canada, we have 1 in the UK, we have 1 in Sweden, okay? Let's imagine they're a country, right? And by the way, if they were a country, they would be as big as Switzerland and Canada in our, right? It's, I think, 40 investigators. So it's much less than actual China, but it's still a pretty large number, right? And you could ask, okay, is their research discounted? And this is the last dot on this graph. What you can see is, okay, it's imprecisely estimated, right? But there is no hint of a discount for those researchers. So I think of this figure as being important in the collage of evidence I'm providing here, because it basically shows 2 things. It shows that first, that discount seems to be a uniquely Chinese phenomenon, right? That's the first thing. And the second thing is, it's kind of hard to look at the last data point here and to say, you know, this discount, that's the result of animus, ethnic animus against Chinese researchers.
Russia, not in chemistry, but you said mathematicians, for example. Would you have said, I was wondering whether some political reasons might be there as well. I mean, you see,
right.
China is
So, no, that's interesting.
I would be very interested looking at citations of, maybe in mathematics or no, some areas, not chemistry, where Russia might have been, or Soviet Union.
Right. So you could think, I think it's going to be...
something similar.
No, I think that's going to be very interesting to do using kind of the Ukraine war, you know, before and after, right? And the thing that's really cool about Russian, well, okay, so let me explain to you one limitation you would have in the Russia example, right, that we also have, right? Because I think what you're asking me, Philippe, is, okay, there's no ethnic animus against the Chinese, but might there be animus or hostility towards the institutions, right? Just you're kind of visiting the sins of the country on the scientific institutions, right? And I think that's legitimate, right? And we can't rule that out. And the fundamental reason for why we can't rule it out is that we do not have, I think there isn't really, but as a result, we do not have foreign researchers in Chinese university. Or if there are, it's a vanishingly small number, and they're certainly not in our data set, right? But that would be kind of but notice that I also think there aren't a lot of foreign researchers in Russian universities. So that would be subject to the same limitation. Yes?
If you want to follow Philippe's idea, I think for Russia mathematics, you should look at the 50s and 60s.
So that paper has been actually, since you're a mathematician, you should know this paper, right? There's this paper by Bojas and Doran that basically looks at what happened to mathematics and to mathematical production in the wake of the fall of the Berlin Wall, right? When all that research that was published in Russian in Russia suddenly became available, and when Russian, mathematicians started to migrate in the U.S. I will send you this paper. It's a very, very interesting piece of work. What?
We cite them more.
Yeah. We cite them more, and they totally crowd out U.S. researchers, right? Right. I mean, you know that. Okay, so let me not present Kirk's paper right now, but it's an interesting piece of work. Okay, Philippe, this is what I told you. I don't know. I don't see kind of a pattern in terms of the temporal evolution of this discount. Right, it goes up and down, kind of mostly down, but kind of quite stable. Okay, so in a few minutes that I have left, right, what we can look at is, what we want to see in some sense is, are there some Chinese investigators that can overcome the China citation discount? Okay, basically, yes. And those Chinese investigators that can partly overcome the China citation discount are those that have at least part of their training in the US, either grad school or postdoc, okay? They don't undo it in totality. They seem to be undoing half of it, right? Of course, what we can see is when the Chinese paper, right, as a US author, happens to have a US author on the authorship list, those papers are not discounted, right? We also find that if one thing we do is we run the author names in all the citing papers through an ethnicity parser, okay? So for Chinese and Koreans, that's very easy, right? Maybe for French names, it's easy, right? But then you have, the German-sounding names and the English-sounding names. We try to do it for the best we can using Trang and Nguyen's kind of ethnic parser. And so what we kind of then can look at is the extent to which having a citer or potential citer with Chinese ethnicity, right, does that help the likelihood of citation in the US? And the answer is yes, it does, right? So Chinese citers, I shouldn't say, individuals with Chinese names in the US are much less likely to discount the research of Chinese researchers relative to German researchers or Canadian researchers. Yes, Dimitri.
So two quick questions. So one is, my sense is in the natural sciences when two labs collaborate, often the labs will switch whose name goes at the end, right? So you have basically, let's say there's a collaboration between a Chinese and a German lab on a project that between
Yep.
the switch whose name is last. I was wondering whether that's maybe something you could explore for
So-
how this gets assigned. And the second question is, you collect this extraordinary set of CV data. Is there any kind of geographical switching where like Chinese researchers, they move their lab to Germany? Or
Yeah.
vice versa? Could that also be an interesting source of variation?
There are such instances, and we can capture, like the question is like, how do we get to label a lab as being Chinese, right? In a world where potentially you can move across borders, including if you are from China, right? This is not the Russia situation from the 1970s. And so first, it happens that in our data, in this particular data set, the number of such instances, you can count on the number of, I think, 1.5 hands, okay? I think we have 7 such cases, right? And then one thing we've done is we've basically looked at, we've taken 3 different kind of approaches. One is you're in the country in which your lab was first born. Then you're in the country, depending on the most number of years in which you've been, within the 20 years of our data set. And then a third solution is you're in the country, you are from the country in which the location in the last year of the data. We've done it every which way. It doesn't change anything, and given the number of observations we're talking about, it's not surprising. But certainly that's something we should have worried about, and we did worry about it. And your first question is, you're correct, but fortunately, and I'm kind of like glossing over some of the details that are in the paper, this is something that's those are things that are totally observable to us, right? So here we're already, you can see that we're playing in the table, right, with whether there's a US cited author in first position, in reprint position, in the middle of the authorship list. We have all of that.
What I had in mind is I sort of assumed that maybe if people just focus on the last author of the paper, let's say there's a collaboration with the Chinese and German lab, you should see the discounts for their set of jointly published papers.
Oh.
The last author name.
I see what you mean.
But when the same collaboration actually puts the German PI at the end.
Got it. Okay. That's a totally interesting thing to think about, right? So kind of like this log rolling thing, if we could, okay, I see. Okay, let me think about that. That's actually a great idea. I think we could do something about this. Okay, I'm going to, I'm over time. Okay, let me, by the way, okay, let me just skip this. Let me just say that discount that we find in publications, we also find in patents, right? Using as the raw ingredient citations contained in patents to papers, stuff that Antonin is very familiar with.
Is it patent to patent as well?
We haven't done patent to patent,
Okay.
but I guess we could. I think it would be quite thin. I think the data would be too thin for us to do, frankly, right? Okay, so what did we do? We're trying to think about what the rapid rise of China in research and science actually means, right? Lots of knowledge is being produced. Is it incorporated in frontier research? And what we find is no, at least not to the extent that one might expect given observables, right? Lots of potential explanation. The one that I think receives the most support in our data is kind of reduced awareness due to shallower networks from Chinese researchers in the US relative to researchers in other countries. And the evidence for that is that discount is reduced for returnees from the US and very focused researchers, and also eliminated when we look at citations from co-ethnic PIs. Okay, let me end here. Thank you.